In the small German town of Ulm on March 14th, 1879, a boy was born who would change the way humanity understood the universe. His name was Albert Einstein. At the time, no one could have imagined that this quiet, slow to speak child would grow into one of the greatest scientific minds the world had ever known. Even his parents, Hermann and Pauline Einstein, were worried in his early years. Albert did not speak fluently until the age of 4, and some feared he might have a learning disability. But Albert's silence was not emptiness, it was thought. Even as a child, he seemed to be deep in contemplation, trying to understand the world around him in ways that no one else could. Albert grew up in a modest household. His father ran a small electrical equipment company, and his mother was a pianist who loved music and education. From an early age, Albert showed signs of intense curiosity. He was fascinated by simple things: how a compass needle always pointed north, why the sky was blue, how light traveled through space. These were not just passing questions. They stayed in his mind for days, even weeks. He would ask his parents, his teachers, and anyone else who might have an answer. Often the answers he received were not enough. He wanted to dig deeper. He wanted to see the hidden layers of nature. School, however, was not a pleasant place for young Einstein. The rigid structure and strict discipline of the German school system frustrated him. He found it difficult to memorize facts without understanding the logic behind them. His teachers did not appreciate his questioning nature. They preferred obedience to curiosity. One teacher even told him he would never amount to anything. But Albert's mind worked differently. He was not content with simply knowing the answer. He wanted to understand the principles behind it. He wanted to know why things were the way they were. One of the turning points in Albert's early life came when he was given a book on geometry. He was around 12 years old, and he devoured the book with incredible excitement. To him, the clarity and certainty of mathematics were like a beautiful language, one that made sense in a world full of confusion. Around the same time, he was introduced to the works of great philosophers and scientists. He began reading about Immanuel Kant, Isaac Newton, and Galileo Galilei. These thinkers sparked something in him. He realized that the universe followed laws, rules that, if understood correctly, could explain everything from the motion of the planets to the behavior of tiny atoms. Albert also had a small laboratory that he built with the help of a family friend. In it, he conducted simple experiments, testing theories he had read about. He was still just a teenager, but he was already thinking like a scientist. His love for knowledge, however, often made him feel isolated. He didn't have many friends, and he sometimes felt out of place among his peers. But in books and in thought, he found a world that welcomed him. His family moved to Munich and later to Italy, following business challenges. These changes disrupted his education, but they also broadened his perspective. In Italy, he discovered art, culture, and the value of independent thought. Eventually, he decided to pursue higher education in Switzerland, enrolling in the Swiss Federal Polytechnic School in Zurich. There, he hoped to find an environment that encouraged creativity and intellectual freedom. But even in Zurich, the path wasn't smooth. Einstein was brilliant, but he often clashed with authority figures. He respected knowledge, but not hierarchy. He wanted to learn on his own terms, and that sometimes meant skipping lectures or challenging professors. Nevertheless, he formed close friendships and continued developing his ideas. He was particularly drawn to theoretical physics, the branch of science that seeks to understand the fundamental laws of nature through abstract reasoning and mathematics. By the time Albert graduated, he was eager to begin a career in science. But the world wasn't quite ready for him. He struggled to find a teaching position. Despite his extraordinary talent, many universities saw him as unconventional, even rebellious. It was a difficult time. He took odd jobs and faced rejection after rejection. But he never stopped thinking. He never stopped questioning. And he never stopped believing that one day he would make a difference. That belief kept him going. That fire in his mind, the one that had burned since childhood, still lit up his thoughts. He had ideas about space, time, and light that he felt the world needed to hear. Ideas that could change everything. And as he walked through the streets of Bern, Switzerland, working at a dull job in the patent office, those ideas continued to grow. They waited quietly like a storm on the horizon. The next chapter in Albert Einstein's life was about to begin, a chapter that would not only prove his genius, but would reshape the world's understanding of reality itself. Chapter 2. Albert Einstein's time at the Bern Patent Office would go down in history as one of the most astonishing chapters in the history of science. From the outside, it was an unremarkable government job. He worked as a technical expert, third class, reviewing patent applications for electromagnetic devices. Day after day, he evaluated the designs and language of inventors from around the country. It wasn't glamorous work, but Einstein, in the quiet moments between patents, turned inward. The monotony of his job gave him the mental space to ponder the deepest mysteries of the universe. In 1905, while still working at the patent office, Einstein produced 4 papers that would revolutionize physics. That year would later be called his Annus Mirabilis, his miracle year. Each paper tackled a fundamental problem and redefined the way the scientific world viewed reality. The first paper addressed the photoelectric effect. At the time, physicists could not understand why light shining on certain metals released electrons. Einstein proposed that light was not simply a wave, but consisted of discrete packets of energy, what we now call photons. This idea challenged the classical wave theory of light and laid the foundation for quantum theory. The second paper explained Brownian motion, the seemingly random movement of particles suspended in liquid. By applying statistical mechanics, Einstein showed that these movements could be explained by the existence of atoms and molecules, tiny particles whose existence was still being debated. His calculations offered the first direct evidence of atoms and molecules. The third paper, which would have been enough to secure any scientist's fame, was on special relativity. In it, Einstein proposed a radical idea. The laws of physics are the same for all observers in uniform motion, and the speed of light is constant regardless of the observer's motion. From these simple assumptions, he showed that time and space are not absolute but relative. Clocks tick differently depending on motion. Distances contract. Mass and energy are equivalent. This led to his fourth paper, a short but stunning follow-up, which introduced the equation that would make him world famous. E equals mc squared. energy equals mass times the speed of light squared. This compact formula revealed that matter could be converted into energy and vice versa. It hinted at untapped power within the atom. These papers were submitted to the journal Annalen der Physik. Einstein wasn't yet an academic, nor did he have access to laboratories or research funding. But through sheer intellectual power and imagination, he changed science forever. The physics community was slow to react at first. Many scholars did not know what to make of his ideas. Some dismissed him as an outsider with little academic training. But gradually his brilliance became undeniable. Despite the revolutionary nature of his work, Einstein remained at the patent office until 1909. During those years, he also began lecturing at universities and attending scientific conferences. He built connections and found mentors who supported his vision. One of them was Max Planck, a prominent German physicist who had pioneered quantum theory. Planck recognized Einstein's genius and helped bring his work into the mainstream. Einstein's lectures soon drew attention. Students and scholars alike were captivated not only by his ideas, but by his humble and thoughtful demeanor. He spoke in a quiet, measured tone, often pausing to find the right words. He was not a flamboyant speaker, but his clarity and depth impressed those who listened. By 1909, he was offered a position at the University of Zurich as an associate professor. Finally, Einstein left the patent office and entered academia full-time. The transition was smooth. Now he had the platform to develop his theories and collaborate with other scientists. He began publishing more papers, refining the ideas from his miracle year, and exploring new directions. During this time, Einstein's personal life was complex. He had married Mileva Maric, a fellow physics student from his Zurich days. They had two sons, Hans Albert and Edward. But their relationship became strained. Einstein was deeply absorbed in his work, and tensions grew between them. Eventually, they would separate and later divorce. This personal turmoil ran parallel to his scientific rise. Einstein moved frequently during these years. From Zurich, he accepted a position at the German University in Prague in 1911, where he continued developing his ideas on gravitation. He then returned to Zurich before being invited to the Prussian Academy of Sciences in Berlin in 1914. This move was significant. In Berlin, he was given the freedom to focus solely on research, without teaching responsibilities. He also became a member of the prestigious Kaiser Wilhelm Institute for Physics. By now, Einstein had become a respected figure in the scientific world. But he had his eyes on a much bigger goal, the unification of physics. He realized that Newton's laws, which had governed science for centuries, were not compatible with his own theories of relativity. Particularly, Newton's concept of gravity as a force acting at a distance seemed inadequate. Einstein believed gravity must be explained differently, perhaps as a property of space and time itself. This belief led to his work on the general theory of relativity, a theory that would take him nearly a decade to complete. He needed to understand how objects moved not just in flat space, but in curved space, how mass could bend space-time, and how that bending could be perceived as gravity. To express this, he needed new mathematical tools, especially those related to differential geometry. Einstein struggled with the math. He consulted with mathematicians like Marcel Grossmann, who helped him navigate complex equations. Slowly, piece by piece, Einstein built his theory. It was not a linear path. He made mistakes. He revised his assumptions. He returned to earlier ideas. But through it all, he remained driven by a sense of wonder and a belief in the unity of nature. Meanwhile, World War I erupted across Europe. Einstein, living in Berlin, was disheartened by the nationalism and violence. Unlike many of his colleagues, he did not support the war. He remained politically detached but morally concerned. He continued his research in difficult circumstances, with limited resources and a crumbling world around him. In 1915, after years of intense effort, Einstein completed the general theory of relativity. He presented it to the Prussian Academy in a series of lectures. The theory proposed that gravity was not a force, but the result of curved space-time. Massive objects like the sun bent the fabric of space, and planets moved along those curves. The true test of the theory would come with observations. According to Einstein, light should bend as it passed near a massive object like the sun. This bending could only be observed during a solar eclipse when the sun's brightness was blocked and background stars became visible. Such an eclipse was expected in 1919. British astronomer Arthur Eddington led an expedition to test Einstein's prediction. Two teams traveled to remote locations, one to Brazil and one to the island of Principe off the coast of Africa. They photographed the stars near the sun during the eclipse. When the data were analyzed, they confirmed Einstein's theory. The stars had shifted positions just as he had predicted. This confirmation was a turning point. Overnight, Einstein became a global celebrity. Newspapers around the world announced that Newton had been dethroned. Einstein's face appeared on front pages. He was hailed as the new icon of genius. Fame, which he had never sought, now surrounded him. But Einstein remained modest. He knew that science was a collective endeavor, and that no theory was final. Still, the recognition gave him new opportunities. He traveled internationally, gave lectures, and met world leaders. He spoke not only about science, but also about peace, human rights, and education. He became a symbol of reason in an age of chaos. As the 1920s unfolded, Einstein continued to explore the frontiers of physics. He worked on attempts to unify the forces of nature, to reconcile quantum mechanics with relativity. Though these efforts did not produce a final theory, they inspired generations of physicists. Einstein had risen from an obscure patent clerk to the most famous scientist of his time. But he remained grounded. He never forgot his early struggles or his love of thinking. He once said, "Imagination is more important than knowledge, for knowledge is limited, but imagination encircles the world." Chapter 3. Albert Einstein stood on the summit of scientific acclaim. His theory of general relativity had redefined gravity and elevated him to global fame. As he traveled the world in the early 1920s, delivering lectures and meeting intellectuals and dignitaries, he was not just recognized for his scientific genius, but also admired for his humble character and humanistic ideals. Despite his discomfort with fame, Einstein embraced his growing platform to speak out on broader issues. Yet, this new chapter in his life was not without complications. Both science and the world around him were changing rapidly, and Einstein would find himself in conflict with the very nature of reality, and with dark political forces rising across Europe. Einstein continued his academic appointments, now dividing time between the Prussian Academy of Sciences in Berlin and international lectures. He was sought after by universities, governments, and media alike. In 1921, he embarked on a lecture tour in the United States, where he was welcomed with admiration and curiosity. During this trip, he was awarded the Nobel Prize in Physics. Strangely, the prize was not for his revolutionary theories of relativity, but for his 1905 paper on the photoelectric effect. The Nobel Committee, still cautious about accepting the relativity theory's radical implications, chose the safer ground of experimental verification. Yet Einstein accepted the honor graciously, acknowledging that scientific recognition often lagged behind discovery. During this time, physics itself was entering a new and perplexing era. The emergence of quantum mechanics, an area that Einstein had helped initiate with his work on photons, was now evolving in directions he found troubling. Young physicists like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger were uncovering principles that defied classical logic. Their work suggested that particles could exist in multiple states at once, that outcomes depended on observation, and that certainty was fundamentally limited. This clashed with Einstein's belief in an orderly, deterministic universe. For Einstein, nature obeyed laws that could be discovered and expressed through clear equations. He could not accept a theory that relied on probability and uncertainty as foundational. His famous objection was encapsulated in the phrase, "God does not play dice with the universe." This phrase became emblematic of the philosophical divide between Einstein and the new generation of physicists. Einstein engaged in intellectual debates with Bohr and others, especially during the Solvay conferences, a series of scientific gatherings that brought together the brightest minds in physics. These debates were respectful yet intense. Bohr argued that quantum mechanics, though strange, worked. Its predictions matched experiments. Einstein, while recognizing its power, insisted that the theory was incomplete. He believed a deeper, underlying reality still awaited discovery. These disagreements did not diminish his stature, but they did mark him as increasingly isolated within the physics community. While many younger physicists embraced quantum mechanics as the new foundation of physics, Einstein remained a lone voice, insisting on a more intuitive, rational explanation of nature. He began working on what he called a unified field theory, an attempt to combine gravity and electromagnetism into a single framework. This pursuit would occupy him for the rest of his life, though he never achieved the breakthrough he sought. Meanwhile, the world outside academia was becoming more unstable. The political situation in Germany deteriorated throughout the 1920s. Economic hardship, resentment after World War I, and the rise of extremist ideologies created a volatile environment. Einstein, a Jewish intellectual with international fame and pacifist views, became a target for right-wing nationalists and anti-Semitic groups. Newspapers and political pamphlets attacked him. Death threats followed. Einstein remained outspoken despite the dangers. He continued to write and speak about peace, international cooperation, and the dangers of nationalism. He joined various humanitarian and pacifist organizations and spoke out against militarism. He believed scientists had a moral responsibility to shape a better world, not just to pursue knowledge in isolation. His Jewish heritage also led him to support Zionist causes, though not in the religious sense. He believed in a cultural and intellectual revival of the Jewish people and supported the founding of the Hebrew University in Jerusalem, where he later served as a board member. As the 1930s approached, the political climate worsened. In 1933, Adolf Hitler came to power in Germany. The Nazi regime quickly began targeting Jews, intellectuals, and anyone perceived as a threat to their ideology. Einstein, already a prominent figure and vocal critic of fascism, realized he could not stay in Germany. That year, while on a trip to the United States, he made the decision not to return. He resigned from the Prussian Academy and renounced his German citizenship for the second time in his life. His home in Berlin was raided, and his books were burned by Nazi supporters. Posters labeled him an enemy of the state. Einstein was deeply saddened, not only for his personal loss, but for the betrayal of a country he had loved. Germany had been the birthplace of his scientific dreams, but now it had turned into a place of darkness. Einstein settled in the United States, accepting a position at the newly formed Institute for Advanced Study in Princeton, New Jersey. This quiet academic community became his refuge. In Princeton, he was given the freedom to continue his research without the burdens of teaching. His daily walks, wild hair, and simple clothing became part of local legend. Despite his fame, he lived modestly and remained approachable, often inviting students and neighbors into his home for conversation. In America, Einstein became more than a physicist. He was now a public intellectual, often commenting on moral, political, and social issues. He wrote essays, gave interviews, and signed letters supporting civil rights, disarmament, and international cooperation. He formed friendships with activists, philosophers, and artists. One of his most famous correspondents was the African-American civil rights leader W.E.B. Du Bois. Einstein openly criticized racism in America, calling it a disease of white people. He advocated for equality and justice in all its forms. Though he continued to work on physics, especially his unified field theory, Einstein's influence was increasingly moral rather than scientific. Younger physicists were now advancing quantum field theory and nuclear physics, areas that he viewed with skepticism. Still, his presence lent dignity and gravity to the scientific community. In 1939, as World War II loomed, Einstein took an extraordinary step that haunted him for the rest of his life. Physicist Leo Szilard approached him with news that German scientists might be developing a powerful new weapon based on nuclear fission. Together, they wrote a letter to President Franklin D. Roosevelt, warning that the United States should begin similar research. This letter helped spur the creation of the Manhattan Project, which ultimately developed the atomic bomb. Einstein himself did not work on the bomb, and he later expressed regret for his role in urging its development. He had feared what a Nazi bomb could do to the world. But after Hiroshima and Nagasaki, he became a vocal advocate for nuclear disarmament and global peace. He joined the Emergency Committee of Atomic Scientists, urging international control over nuclear weapons. As the war ended and the Cold War began, Einstein grew increasingly disillusioned with politics. He was concerned about McCarthyism, the growing influence of the military-industrial complex, and the erosion of civil liberties. Still, he never lost faith in reason, dialogue, and human potential. He believed in the unity of mankind and the necessity of world government to prevent future wars. In his final years, Einstein focused on refining his unified field theory, writing letters to colleagues, and reflecting on his life. He received countless honors and invitations, but turned most of them down. He preferred solitude and the company of close friends. He once said, "I live in that solitude which is painful in youth, but delicious in the years of maturity." In 1955, Einstein passed away in Princeton at the age of 76. His brain was removed for scientific study, but his body was cremated and his ashes scattered in an undisclosed location. He had requested no monuments or grand tombs. He wanted to be remembered not as a hero, but as a seeker of truth. Chapter 3. As the 1920s progressed, Albert Einstein found himself at the epicenter of global attention. Having become a household name after the confirmation of general relativity in 1919, Einstein now occupied a position no scientist had before. An international celebrity, revered as much for his intellect as for the aura of mystery surrounding his insights. Invitations poured in from around the world. He visited the United States, Japan, South America, and Palestine, meeting with scholars, heads of state, and curious citizens alike. Yet, behind the fame and acclaim, Einstein's mind remained intensely focused on the puzzles of nature that still evaded explanation. One of these puzzles was the new and rapidly developing field of quantum mechanics. In the early 1920s, a generation of young physicists was beginning to uncover strange behaviors of particles on the smallest scales. Werner Heisenberg, Niels Bohr, and Erwin Schrödinger were among the pioneers pushing the boundaries of what physics could describe. Unlike Einstein's deterministic worldview, where outcomes could be predicted given the right information, quantum mechanics introduced probabilities. It suggested that at the most fundamental level, nature was governed not by certainty, but by chance. Einstein, though intrigued, was deeply skeptical. He had played a foundational role in quantum theory with his work on the photoelectric effect, yet the philosophical implications of quantum indeterminacy disturbed him. He could not accept a universe in which particles did not have definite properties until measured, or where reality seemed to depend on observation. This led to one of the most famous debates in the history of science. Einstein and Bohr, two of the greatest minds of the century, clashed in a series of intellectual battles that spanned decades. These debates, which took place at scientific conferences and through published papers, revolved around the nature of reality itself. Einstein would devise thought experiments to challenge quantum mechanics, attempting to show that the theory was incomplete. Bohr, with equal brilliance, defended the probabilistic framework. Einstein's most famous critique came in 1935 in a paper he co-authored with Boris Podolsky and Nathan Rosen, now known as the EPR paradox. The paper argued that if quantum mechanics were correct, then particles could instantaneously affect each other over vast distances, a phenomenon Einstein derisively called spooky action at a distance. This, he believed, contradicted the principle of locality, which stated that objects could only be influenced by their immediate surroundings. Einstein insisted that a deeper, hidden layer of reality must exist, one governed by deterministic laws. While Bohr and most of the physics community accepted quantum mechanics as the best available theory, Einstein remained unconvinced. He was not opposed to the mathematical success of quantum theory. Indeed, he acknowledged its predictive power. But he sought a more complete theory, one that reconciled the weirdness of the quantum world with the coherence he believed nature must possess. During these scientific debates, Einstein's personal life underwent profound changes. In 1921, he had been awarded the Nobel Prize in Physics, not for relativity, but for his explanation of the photoelectric effect. This recognition brought financial security and global prestige. However, his relationships continued to evolve. He had divorced Mileva Maric in 1919 and soon married his cousin Elsa. The new marriage brought some domestic stability, though Elsa often struggled with the demands of being married to such a public figure. Einstein also became more politically engaged. He supported pacifist causes and spoke out against nationalism and militarism. The devastation of World War I had left deep scars across Europe, and Einstein emerged as a vocal advocate for peace and international cooperation. He joined the League of Nations Committee on Intellectual Cooperation and used his fame to promote disarmament and human rights. Yet the political climate in Germany was growing increasingly hostile. The post-war years had seen the rise of economic hardship, social unrest, and the gradual emergence of radical ideologies. Anti-Semitic sentiments, long present in European society, began to intensify. As a prominent Jew and an outspoken intellectual, Einstein became a target. Right-wing groups in Germany accused him of undermining traditional values and promoting Jewish science. In the early 1930s, the situation worsened dramatically. Adolf Hitler and the Nazi Party rose to power, bringing with them a brutal agenda of racial purity, authoritarianism, and aggressive nationalism. Einstein, who had been working at the Prussian Academy of Sciences and living in Berlin, found himself increasingly at risk. His lectures were disrupted, his books were burned, and threats against his life grew more frequent. In 1933, while on a trip to the United States, Einstein made the painful decision not to return to Germany. He resigned from all official positions and severed ties with German institutions. His beloved homeland had become unrecognizable, a place where science was no longer free, and where his own existence was seen as a threat. Einstein accepted a position at the newly established Institute for Advanced Study in Princeton, New Jersey. There he would spend the rest of his life. Princeton provided a quiet refuge where he could think, write, and walk in peace. But he never ceased to mourn what had been lost. The exile from Germany was more than a relocation. It was a severing of roots, a forced abandonment of a cultural and intellectual heritage that had shaped him. Despite the trauma of exile, Einstein continued to engage with the world. He became a fierce critic of fascism and totalitarianism. He warned of the dangers posed by Hitler and urged nations to resist the spread of tyranny. At the same time, he remained committed to scientific work. Though he would never fully embrace quantum mechanics, He kept searching for a unified field theory, a grand explanation that would link all the forces of nature. Einstein's time in Princeton was marked by both solitude and outreach. He received letters from admirers, students, and fellow scientists from around the world. He answered many of them, offering encouragement, advice, and reflections. He gave public talks, wrote essays on philosophy, religion, and politics, and remained an enduring symbol of wisdom and compassion. As the 1930s drew to a close, a new storm was brewing. The world was on the brink of another devastating war. In the next section, we will explore Einstein's role in the events leading up to World War II, his involvement in the development of atomic weapons, and the profound ethical questions that would shape the final chapters of his extraordinary life. Chapter 4. Albert Einstein arrived in the United States in 1933, stepping onto American soil not just as a scientist, but as a refugee, philosopher, and symbol of freedom. The political situation in Germany had become unbearable for him. As Adolf Hitler came to power and anti-Semitic laws were passed, Jewish scientists were expelled from their posts. Einstein, a Jew and outspoken critic of Nazism, had his house raided and his books burned in public demonstrations. When offered a position at the newly formed Institute for Advanced Study in Princeton, New Jersey, Einstein saw an opportunity to continue his work in safety. At Princeton, Einstein was given the freedom he had always longed for. He had no teaching obligations, no administrative duties, just the time and space to think. His office was modest, his dress even more so. He was often seen walking the streets of Princeton in an old sweater, no socks, and a relaxed air that belied the intensity of his thoughts. Despite his fame, he remained deeply humble and approachable. Children would knock on his door asking for help with homework, and he would patiently assist them. Einstein's work in America shifted from the revolutionary discoveries of his youth to a more philosophical and unifying vision. He sought a unified field theory that would merge the forces of nature into a single framework. General relativity explained gravity as the curvature of space-time, but electromagnetism and the emerging field of quantum mechanics remained disconnected from it. Einstein believed that beneath the apparent randomness of quantum theory, there must be an underlying order. This belief brought him into conflict with many younger physicists. Quantum theory was advancing rapidly and with tremendous experimental success. It posited that the universe was inherently probabilistic, that particles didn't have definite positions until measured, and that reality itself was shaped by observation. Einstein could not accept this view. He famously remarked, "God does not play dice with the universe." Einstein's objections weren't born out of stubbornness, but from a deep philosophical conviction. He believed the role of science was to uncover the rational order of the universe. For him, the unpredictability of quantum mechanics was a sign that the theory was incomplete. He worked with colleagues like Nathan Rosen and Boris Podolsky to develop thought experiments like the famous EPR paradox that challenged the completeness of quantum mechanics. Though these efforts didn't overturn the quantum worldview, they sparked debates that continue to this day. In Princeton, Einstein became more than a physicist. He grew into a public intellectual. He wrote essays, gave speeches, and participated in social causes. He spoke against racism in America, comparing it to anti Semitism in Europe. He supported civil rights leaders like W.E.B. Du Bois and Paul Robeson. He was one of the few white intellectuals to stand openly against segregation and injustice, using his fame to lend credibility to the cause. During World War II, Einstein's name became associated with the atomic bomb, though he did not directly participate in its development. In 1939, he signed a letter to President Franklin D. Roosevelt, warning that Germany might be developing nuclear weapons. The letter, drafted by physicist Leo Szilard, led to the formation of the Manhattan Project. However, Einstein was not invited to join the project due to concerns about his pacifist beliefs and political leanings. After the war, Einstein was haunted by the destructive power of the bomb. He became an advocate for nuclear disarmament and global cooperation. He helped form the Emergency Committee of Atomic Scientists and used his platform to promote peace and responsible science. He believed humanity stood at a crossroads between wisdom and annihilation. Einstein's daily life in Princeton was simple. He enjoyed playing the violin, sailing, and long walks. He received visitors from around the world, scientists, students, political leaders, and curious minds. He answered letters from people of all ages and backgrounds. Despite his towering intellect, he never lost touch with the human side of life. In the late 1940s and early 1950s, Einstein continued his work on the unified field theory, though progress was slow. Younger physicists were captivated by quantum electrodynamics and other new theories. Einstein, increasingly isolated in his views, pressed on with quiet determination. He believed that future generations might one day see the value in his approach. He also continued to reflect deeply on philosophical and ethical questions. He corresponded with thinkers like Bertrand Russell and discussed topics ranging from religion to education to the meaning of life. Einstein believed in a cosmic religion, a sense of awe at the structure of the universe, devoid of dogma or supernatural elements. He often said, "Science without religion is lame. Religion without science is blind." As the Cold War intensified, Einstein's voice remained one of reason and conscience. He opposed McCarthyism and defended intellectual freedom. He warned of the dangers of nationalism, militarism, and blind allegiance to authority. He urged scientists to act as guardians of humanity, not servants of power. When Israel was founded in 1948, Einstein was offered the presidency of the new nation. He declined, saying he lacked the experience and temperament for political leadership. Still, he supported the idea of a homeland for Jews and continued to raise funds for educational and scientific institutions in Israel. Einstein's health declined in the early 1950s. He suffered from abdominal aneurysm and other complications, but he continued to work until the end. In April 1955, he passed away quietly in Princeton Hospital. In accordance with his wishes, his body was cremated and his ashes scattered. No grave, no monument, just a legacy that would echo through the ages. Einstein's brain was preserved for scientific study, though this decision remained controversial. Researchers hoped to find clues to his genius, but the secrets of his mind lay not in anatomy, but in his relentless curiosity, creativity, and compassion. By the time of his death, Albert Einstein had transformed from a rebellious student into a global icon. He had reshaped our understanding of space, time, energy, and matter. But perhaps more importantly, he had shown that science could be a moral force, a path to truth, and a guide for humanity. Chapter 5. As Albert Einstein entered the later years of his life, he stood as a towering figure in the world of science, a name recognized far beyond the confines of academia. Yet, while the world saw him as a genius and a celebrity, Einstein remained focused on deep questions that transcended personal fame. The second half of his life was marked not only by continued scientific exploration, but also by moral leadership, philosophical inquiry, and an unwavering pursuit of truth in a rapidly changing and often chaotic world. By the 1930s, the political situation in Germany had taken a dark turn. The rise of Adolf Hitler and the Nazi regime posed an immediate threat to Jews and intellectuals. Einstein, who had long been vocal against nationalism and militarism, was especially at risk. His Jewish heritage and pacifist views made him a target of the regime's propaganda. Realizing the danger, he left Germany for good in 1933 and accepted a position at the newly established Institute for Advanced Study in Princeton, New Jersey. There, he would spend the remainder of his life. In Princeton, Einstein found a peaceful environment where he could think and write freely. Though he had escaped the dangers of Europe, he never ceased to speak out against tyranny and injustice. He became a symbol of resistance to fascism, using his platform to advocate for democracy, human rights, and world peace. He supported the civil rights movement in America and formed friendships with prominent activists, including W.E.B. Du Bois and Paul Robeson. Though he spoke with a thick German accent, his words resonated across cultural and national lines. While Einstein's political voice grew stronger, his scientific curiosity remained undiminished. He turned his attention to a grand challenge, the quest for a unified field theory. This theory sought to merge gravity and electromagnetism into a single framework. Einstein believed that the fundamental forces of nature were manifestations of a deeper unity, and he dedicated the final decades of his life to discovering that unifying principle. However, the world of physics had changed dramatically. Quantum mechanics, which Einstein had helped pioneer with his 1905 paper on the photoelectric effect, had evolved in ways he could not accept. The probabilistic nature of quantum theory, exemplified by Werner Heisenberg's uncertainty principle and Niels Bohr's Copenhagen interpretation, troubled him deeply. Einstein famously declared, "God does not play dice with the universe," reflecting his belief that the universe must operate according to deterministic laws. Einstein engaged in a long and respectful debate with Bohr and other quantum physicists. Though he admired their brilliance, he disagreed with their interpretation of quantum mechanics. He proposed thought experiments, such as the Einstein-Podolsky-Rosen paradox, EPR, to highlight what he saw as inconsistencies. These debates became legendary and helped define the philosophical foundations of modern physics. Despite his objections, Einstein could not ignore the impact of quantum theory, especially as it led to practical applications like nuclear energy. When news reached him in the late 1930s that German scientists had discovered nuclear fission, Einstein grew concerned. He feared that the Nazis might develop an atomic bomb. In 1939, he signed a letter to President Franklin D. Roosevelt, written by physicist Leo Szilard, urging the U.S. government to accelerate research into nuclear chain reactions. This letter led to the establishment of the Manhattan Project. Einstein himself did not work on the bomb, nor was he involved in the classified research of the Manhattan Project. In fact, the U.S. government considered him a security risk due to his pacifist views and left-leaning political associations. Nonetheless, he was deeply troubled by the use of atomic weapons on Hiroshima and Nagasaki. After the war, Einstein became a leading advocate for nuclear disarmament, warning humanity of the destructive power it now possessed. In his final years, Einstein became more philosophical. He wrote essays on ethics, religion, and the role of science in society. He believed in a cosmic religion, a sense of wonder and humility in the face of the universe. Though not religious in a traditional sense, he often spoke of a spiritual awe inspired by the order and beauty of the cosmos. To Einstein, science and spirituality were not opposing forces, but two ways of approaching the same mystery. Einstein's personal life during these years was quiet. He lived in a modest home in Princeton, wore simple clothes, and shunned publicity. He continued to correspond with scientists, students, and world leaders, always willing to share his thoughts and encouragement. He played the violin, walked daily, and enjoyed sailing, though he was famously poor at it. His warmth, humor, and humility endeared him to those who knew him. On April 17, 1955, Einstein experienced internal bleeding caused by the rupture of an abdominal aortic aneurysm. He was taken to the hospital, but he refused surgery, saying, "I want to go when I want. It is tasteless to prolong life artificially." He died the following morning at the age of 76. His body was cremated, and his ashes were scattered at an undisclosed location in accordance with his wishes. Einstein's death marked the end of an era, but his influence lived on. His theories became the bedrock of modern physics. Technologies like GPS, nuclear power, and semiconductors all owe something to his insights. More than that, his example of intellectual courage and moral integrity continues to inspire scientists and non-scientists alike. His name became synonymous with genius, yet he always emphasized imagination, curiosity, and kindness. He once said, "Try not to become a man of success, but rather try to become a man of value." In an age of rapid change and existential challenges, Einstein's life remains a beacon, a reminder that the pursuit of knowledge, guided by compassion and humility, can change the world. As we close the final chapter of his story, we remember not just the man who reshaped our understanding of the universe, but also the human being who dared to ask profound questions, stood up for what he believed, and inspired generations to follow the light of reason and the dream of peace.